This is a review of the Edgenuity lesson, graphing logarithmic functions. So first, let's talk about what is log? What does that mean? What logarithmic functions are, they're the inverses of exponential functions. So similar, like when we talk about inverse operations, how adding and subtracting undo each other. So if you had x plus 8, to undo the plus 8, you would subtract 8. Or like multiplying and dividing undo each other. So if I had 10x, I would divide by 10 to get rid of it. Or squared and square rooting undo each other. Logarithms will help us solve exponential functions when we get to that point. So some examples of what an inverse of an exponential function and a logarithmic function look like. So if I had log base 3 of x, the inverse of that is 3 of x. So when I say log base 3, notice how the 3 becomes the base of the exponential function as well. So if I had log base 7x, the inverse of that is 7 to the power of x. So this number again becomes the base in our exponential function. And lastly, log base 2 of x, the inverse of that is 2 to the power of x. Those are inverses of each other. So when you graph, so this first one, we're going to graph y equals log base 3 of x and eventually state the domain and the range. You make a table of its inverse. So we're going to write it in exponential form, and then we're going to make a table of that because it's easier to do it that way than to do a table with log base 3 of x. And then because it's the inverse, all we have to do is switch the x and the y's, and that will be the graph of log base 3 of x and plot those points. So what I mean by that, so if I have log base 3 of x, first you have to think of what's that inverse. That would be 3 to the power of x is the inverse. So then if I made a table of 3 to the power of x, I guess I'll just do this. That would give me my y coordinates. Let's just do -1, 0, 1, and 2. 3 to the power of -1. Remember, you can't have a negative exponent, so you just put a 1 on top. And 3 to the first power is just 3, so we end up with 1/3. 3 to the power of 0, anything to the power of 0 is just 1. 3 to the first power is 3, and 3 squared is 9. Okay, so now again, these are the ordered pairs for the inverse, 3 to the power of x. So if I wanted to figure out how to graph log base 3 of x, you just take the x and y coordinates and you flip them. So the first ordered pair would be 1/3 -1, 1, 0, 3, 1, and 9, 2. So what I'm going to do now is I'm going to plot those 4 points on my coordinate plane here. So the first one, we're going to go right 1/3, down 1, right 1, then 0. Then the next one is 3, 1, and 9, 2. So 3, 4, 5, 6, 7, 8, 9. Okay, so when you have a logarithmic function, it does have an asymptote, but it's different than the exponential functions because, like I said, they're inverses of each other. So logarithmic functions will have a vertical asymptote. So you cannot go across the y-axis unless you are shifted left or right. So with exponential functions, when we shifted up and down, the asymptote went with us. With logarithmic functions, if you have shifts that move you left or right, so things that are added or subtracted, that's going to move your asymptote. We don't have any shifts on ours. It's just log base 3 of x. There's no plus or minus that's going to change anything. So again, like I said, you cannot go across the y-axis. So it ends up looking like this. Okay, so now another thing that switches between exponential functions and logarithmic functions is on logarithmic function, the range is always all real numbers every single time. You don't even have to think about it. For logarithmic functions, The range is always all real numbers. Now the domain, you'll notice, there are no negative x values right now because I told you can't go across the y-axis. Well, all the negative x values are over here. So, and we're never actually going to be 0. So this graph is just going to go to the right forever. It starts basically as close as it can get to 0. So the domain for this is going to be x has to be greater than 0. Now again, if this were to shift left or right, the domain would shift left or right with it. So if it went to the left too, you would change this to a negative. I'll give you an example of that next. So these shifts, if you have to graph something with shifts, we have talked about this a lot. Every time we do shifts, it's very similar. So the number in front, this A, it's in charge of stretching, compressing, or if it's negative, it's a reflection. So it'll flip it upside down. If there's ever a number inside parentheses, that's in charge of moving left and right. And when you're going left and right, it's kind of like the opposite. If it's x minus 3, you're going to move to the right 3. If it's x plus 4, you're going to move to the left 4. And if there's ever some number over on the side that's being added or subtracted, not inside the parentheses, that's in charge of moving up or down. So that one's straightforward. If it's positive, you're going to go up. If it's negative, you're going to go down. So let's do one where there are shifts. So this one says graph y equals log base 2 of x plus 1 plus 3. So the first thing we have to do is we have to look at its inverse of log base 2. Now, when you do this, if there are any shifts, you ignore them. All we care about is this part. Okay, so remember, if I had y equals log base 2 of x, because this is all we care about right now, the inverse of that is y equals 2 to the power of x. So what I'm going to do is I'm just going to make a table of this. And I'm going to use the same values as before. Negative 1, 0, 1, and 2. 2 to the power of negative 1. Can't have a negative exponent, so we just put a 1 on top. 2 to the first power is just 2, so we end up with, I don't know what I'm doing, a half. 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of 1 is 2. 2 squared is 4. Okay, so remember, that was the inverse though. So if we want to do log base 2 of x, I'm going to flip all of those ordered pairs. So it's going to be instead 1/2, negative 1, 1, 0, 2, 1, and lastly 4, 2. So I'm going to plot those 4 points there on my graph. 1/2, negative 1, 1, 0, 2, 1, and 4, 2. Okay, this isn't my final answer though, because I have shifts that we just haven't talked about yet. So what I'm going to do is I'm just going to dash this in, because like I said, it's not my final answer. Don't go across the y-axis, because we haven't shifted at all. I'm not going to put the asymptote in there yet, because we have some things that might change it. So looking here at our original function, inside the parentheses, we have a plus 1. So if I was teaching this in class for real, what we would do is we would write the book. And that's basically tell me what the shifts are. So inside the parentheses, remember that's in charge of left and right. Because it's x plus 1, that means I have to shift this to the left 1. And then there's this number outside the parentheses that says plus 3. So that means I'm going to go up 3. So all 4 of these points, I'm going to take them left 1 and up 3. Sorry, left 1, 1, 2, 3. Lastly, left 1, 1, 2, 3. Okay, so because we shifted to the left 1, that means our asymptote went with it. Instead of being on the y-axis, it's going to go to the left 1 and be at negative 1. So if I fill in my answer here, I'll do the Final answer solid. Don't go across tote. Okay, so now the domain and range of this function, range is always all real numbers on logarithms. The domain, since we shifted it to the left one, that means now our domain is x is greater than -1. So it's basically wherever your asymptote is, you'll just put x is greater than whatever the asymptote is.